Yes. Hi guys. I know this is the first time today for you guys to see me, but this is my fourth trying to record. I've had some system issues and yeah, I've stuttered too much. And till now, I don't have an editing software, which I'm trying to download and configure. So until then, I have to do everything in the first try. So that's why I'm recording it for the fourth time, and hopefully I'll make things right. So, last time we talked about uh, two pointers, uh, one of the most used algorithms in a array and strings. Today we're going to talk about sliding windows. It's also one of the techniques that's mainly used in the array domain. Uh, I've looked at some problems for array and strings. It seems like m- most of the problems, so more than 1500 problems on LeetCode, are just from strings and arrays. So I think to get a best, most value out of um, the least work, which I don't advise. Of course, you would have to practice. But yeah, time, depending on the time, considering the time, the best investment could be made on mastering these techniques from arrays and strings. So yeah, without further ado, we're gonna dive right into it. Uh, yeah, so what is a sliding window? Sliding window is an algorithm that uh, is used when a question asks to find subranges in the array to give the longest, shortest, or target values of string. So these longest, shortest, target values are usually implemented with k. So they ask you to find a k, and these subranges are could be from arrays with string or with numbers, or it could even be a list, depending on the language that you use. Um, I'll show you a quick example. So let's say there's an array like this, and you have to find a um, sub-array, which is a partial array of size 2. So the size is fixed, so the k is fixed, but then you'd have to find a subarray that has um, the biggest sum. So what you do in this case, you don't have to find it using nested loops, and that would be a brute force. And um, using loops over loops over loops, that will exponentially increase the time complexity. So if you use this method instead, you can uh, solve this problem within ON or at maximum ON log n. This is because you don't use a loop. You use a loop, but you don't use a nested loop. So what you do is it's basically based on the idea that you define a subarray. Then this subarray will either move towards the end of the sequence, end of the array like this. So increment by one, increment by one, increment by one until the end. Try to find what the problem is asking you to find. Or else, there's also other kind of problems where you'd have to um, the k is not fixed. So the range of value, so um, the sliding window may be from maybe have the same left bound value. So the pointer is still here, but only the right pointer is moving by one, so the array size increases. But this is also a part of a sliding window algorithm. So our job is to master this technique. There are different templates. Um, for a novice like me, I like to use template because it helps me memorize it, and um, when I memorize it and try to use it in different situations, I'm gonna gradually learn how to use it myself and apply it. But yeah, if you master the technique, then you don't have to use a template. But for now, I recommend using it. Template is something like this. If you have a fixed value, so if you want to find a subarray with fixed size, then um, you define a current window of size k in the start, and then you initialize it, and then after that you try to do the calculation. Yeah, and there's going to be uh, initialization of the movement of the pointer, but that we're going to explain. Also, a core idea behind this algorithm is that uh, so whenever a write, so let's say you're defining a subarray of length 2, and then you want to move to the next. So you move the pointer to the right, but then at that time point you have an array of length 3, which if in the case when k is 2, that shouldn't be right. So what you do is you also move the left pointer to the right side to keep the length as 2. So that's what you also have to specify when writing your code. So today I want to actually write a code with you guys and see how this can be implemented. I've already done a couple of tries, so this time I'll be able to do it perfectly, hopefully. So we're going to start with a problem where the k is already defined and is fixed. And it's a, I think, easy problem around 600 mark. Yeah, this one. Yes. So the problem is this. You're given an integer. Oh. Whoop. Not supposed to. Yeah. So you're given an integer array nums of n elements and an integer k. You're trying to find a contiguous subarray whose length is equal to k that has a maximum average value and return this value. So given an array of integers, you're trying to find a subarray that has the maximum average value, and the k is fixed. So the length of the subarray is fixed. So as you can see from the example, from this example, the k is 4. So you can already see with the naked eye that this is going to have the biggest average value. But how do we do it with the code? So, like I said, with the fixed k value, you first start with initializing the current window size. So we're going to define that as current window equals 0. Indentation. And then within this window, in range k, you have to try to visualize it as a conveyor belt. So you're initializing this conveyor belt where there's going to be a sliding window. So you do that by nums I. Yeah, this should be it. So you initialize the current window with a 0, and based on the k size, you're adding the you're specifying the size of the window. Now you're going to initialize the answer to the current value, which is the sum of first k elements. So that will be I don't know why I made a space here. Coding, I've never done a coding test before. At least actually just once, but I've never explained while coding. So this is quite a challenge. Okay, so what you do now is actual calculation. Like I said in the beginning, you initialize the window, and then at the second paragraph, you do the calculation. Of course, this could be changed, but yeah, as per the template, that's what you do. So for I in range to k, right? K and length of nums. So that's going to be the boundary. We add one element and then remove one element. So like I said, you add one element at the right side, and because you added one element at the right side, you have to keep the length of the subarray, so you have to take out one element from the left side. So that's what you do here, current plus nums I, and then to minus the left element, so which is I minus k. Yeah, and then finally you have to specify the you have to see which one is higher, so, because there's a for loop getting engaged here, so you keep on trying to find the maximum value by sliding. So you calculate one here, and then if the next one is bigger, you change that one. So how you do that is just simply by, you can also use the if statement, but you can also do like this. Current window. I don't know why I keep on doing current. Maybe I should reduce the make it more simple, the variable name. Okay, now you're returning the average value, right? So that will be answer divided by the length of the subarray, which is k. So hopefully we haven't done any mistake, and this should be correct. No. I don't know why I did this here. Yeah, so we got it here. K, when K is 4, we get 12.75, which is expected to be 12.75. So that was it. It's pretty simple, right? So we do the initialization of the window. We specify the length of the window, and then yeah, we do the calculation here. Yeah, so this is the easy type of algorithm question on LeetCode using the sliding window, and it's using the fixed size of k. Now we're going to move on to the question that uses the varied type of k, and I believe that has the medium difficulty. I don't think if I was given an easy question right now, then I would be able to solve it easily like this, because I already practiced it in the morning. That's why I can solve it. But yeah, medium question is harder. Okay, I think it's this one. Yeah. Oh, oops, I was trying to solve it. Morning as well. Yeah, so how would you start this? So basically, the k is dependent, so it's depending on the variable. So given a binary array nums and an integer k, we have to return the maximum number of consecutive ones in the array if you can flip at most k zeros. What it means is that so if the k is 2, we can only flip 2 zeros. And given we can flip 2 zeros, we have to find the longest subarray. So yeah, with our naked eye, we can already see that this will be the answer, but how will we code it? So when the k is not fixed like this, you usually have to define the left side only, because the right side you have to keep on moving. The right pointer you have to keep on moving, and also you have to define one variable that's needed for calculation, which is I believe in this case the maximum number. You also have to, in this case, you have to keep the variable where you count the number of zeros that you use, right? No, not the one that you use, but we have to keep the count of the zeros because we have to compare which one can have the maximum number of consecutive ones. Yeah, to compare. That's what I meant. Okay, so like I said, we have to define the number of the max to initialize it as a 0. So max num has to be 0. What else? 0 count has to be 0. And left also has to be 0. So that's the left pointer. So that's going to be 0, 0, 0. I saw yesterday also on a YouTube short that apparently you have to use a PEP8 format. When I used to take programming courses at university, they always say just stick with your own way of formatting. But I guess as you become a professional, you have to stick to a general guideline. Yeah, so back to the real problem. Now what you do is, so you should start sliding the windows, right? You should start sliding the windows because the left is already initialized. You have to slide the windows with the right pointer. So how you do that is for right in range, we're initializing the right pointer. Range nums is a list, and so when we initialize the right pointer, and if the right pointer is pointing at 0, then the 0 count has to be more than 1, right? A 0 counter has to be added. So we're going to first specify that constraint. So if right, no, it's nums right equals 0, then 0 count 1. Yeah, you have to care about the formatting. Yeah, and now that we have done this, so we have to see when so the conveyor belt is going to keep on rolling until the number of 0 exceeds k. So we have to specify that. So while 0 count is more than k, so when it exceeds k, that means that we have to move the left side as well. So that means if the left pointer, so nums left, is also 0, we have to Okay, first add it to the zero count variable, because that's what we're ultimately trying to solve. And yeah, we move the left pointer to the right, so we do that by adding 1, and that's going to yeah, I think that's the calculation part. No, that's the sliding window part. Now we have to calculate like what we did in the previous problem. So we have to calculate the maximum number of maximum number. And how we do that is also by using a loop that's already being initialized. So max num is max num. Yeah, so if the max num is higher than the so we're trying to find the longest, so we have to find the length, which is right pointer minus left pointer, the location of the left pointer plus 1, right? So if the array that's being calculated here is bigger than the previous max number, then it's going to replace the max number. So we do that, and then finally we return the max num, and we see if this is correct. Indentation probably is correct. Yeah. Okay, so 0 count. Yeah, that one. Okay, it's always the indentation. Yeah. Is this? Which part is? Yeah, for if, while if. Zero count is right. Max num is right. Huh? What am I missing? Num. Yeah, num's left. If num's left equals 0, 0 count plus. Index out of range. Subarray is both the numbers were flipped from 0 to 1. 0 count. Num's left. Right minus left plus 1.